Yeah. Hello everyone. My name is Hiren, and today we are going to wrap this session on digital image processing, which we started in the last week. So this is the extra class where we will finish all those things related to the digital image processing. And in the last two lectures, we will see a bit more on GIS part, basically multiple choice questions and other questions on that, as we have already covered like hands-on sessions on that like before only. So I think one session we will do some case studies on QGIS, and then in one class we'll solve the question and answers. With this, we'll start today's session. So basically, now today's section is divided into two different parts. The first part is like we have to find out the what is the size and the resolution, like given the resolution of the image and the bands it has, how much space it can occupy basically in your storage. And then another type of questions which is on types of filters and some questions on that. So let's get started. So we'll start with this question that where number of bytes are required to store an 8-bit uncompressed image of size 512 by 512 pixel will be the how much. So how will we proceed to solve this?
Is 2 GB. Your internet is
Yeah. Am I audible?
you're stuck.
Am I audible? Yeah. Am I audible? Just, yeah. Am I audible now?
Yes,
Yeah.
went away for a while. Okay, 2
Okay.
GB.
Okay. Okay. So I mean the you have to go through the question. Like in question, it is asked in number of bytes, not in GB. So
Okay, sorry.
So like I will open my calculator as well. So we'll solve along with. So here it's given to us is like 512 by 512 pixels. So first of all, like we will calculate how many total pixels are there in a given image. So for that, we'll just do the multiplication, both the dimension, x and y. So we have around 262,144 pixels. Now each pixel will like occupy 8 bits, which is equivalent to 1 byte. So it is like same answer we will get. So this number of pixels and each pixel will occupy 1 byte. So our answer will be like is equal to 262,144 only. If
Correct.
okay, yeah. In case they
That's
ask,
why bit by it, that happened. Okay.
yeah. So now if we will convert into KB kilobytes, then it will be like 256 kilobyte, and if further if we will convert into megabytes, then it's 0.2 MB, 0.25. So it depends, like you have to go through 1024. So then after we have the next question. So this is the answer of the first question. So the next question is a field of view of a sensor is given. So it is a 90-degree and the nadir height is 6 kilometer. So we have to find out the ground swath of the image, particularly width. So any idea like how will we proceed? So what is
Yeah, I
given
think
here? Yeah,
the height given and 45 degrees will be the angle, and then
yes,
2 times this thing will be the
exactly.
total.
So if the angle is 90 degrees, we will divide it into two like this. If it is the given angle is 90 degree, so this will become 45 and 45. So if this distance, Nadir height is given 6 kilometers, so this will also become 6. And if we consider the ground swath, which is like from here to here,
12
then it will
kilometers.
become how much? 12.
12. Yeah.
So it will become 12. Then the third question is like the pixel value for three band 8-bit image, which is 127, 127, 127, which is the RGB values. So you have to say like which color you will see if the RGB value is like this. So we know that if it is 255, 255, 255, we'll get white. If it is 000, we'll get black.
Yeah, so this is somewhere gray for our grayscale images, but when you put them together,
Exactly. So I mean, if it's gray only because like if we see 256, so it's like half in between. And like further we will check like how will it respond as well. So we'll just open Paint and check it out. So let's say if we take any color value and then let's just check it out the 27. So it's a totally gray color. But now let's say we will try to write something similar in all the three values. Like if RGB both are similar, let's say RGB. So someone may ask you like if the RGB composite it has same value like A or BBB or any kind of numbers basically.
then it's a
So
grayscale.
it
Okay.
will be grayscale image totally. So that we have shown. We'll just try it with some other values as well. So it's like gray range only. So if we go towards 255, 255, it will become like pure white. If it's 000, it will become black. And then if all the three are similar, it will give us the gray band, which you also see here. Like if I just change now here from this to this, it will have similar value and you will get a gray scale image. So now we'll move to the next question. So the next question is to store an 3-band 4-bit 512 by 512 image. How much storage is required? Like how many bits are required? So it's like previous question. Uh,
3145728
yes, exactly.
bits.
So how we'll do it? Like 512 by 512. So we will get total number of pixels in the image. Now this image has 3 bands. So we will multiply the image with the 3 and then it has 4 bit. So like it's like if we have to take half, like 8 bit, it means 1 byte. So if we take just half of it, so oh sorry, not this one. So 512 by 512 will get total number of pixels. Now into 3, it means we will get total number of pixels and then we will multiply it by 4. So we will find out the total number of bits only. Here they did ask us in a byte. If they ask in byte, you have to convert into terms of byte. Okay. So now the next one is like consider an like image which has an across the track multispectral scanner with the ground pixel size of 56 meter and 79 meter. So this 56 meter is the along track and then 79 is across the track. So if we just draw this thing like first of all we will understand the question, loading it. So like if satellite is going in this direction, so let's say if this is your satellite and this will become the along the track direction and the direction on ground which is transverse or like 90 degree to it will become the across the track dimension. So if we take any pixel in an image, then this is pixel. So this 56 meter is the along the track. So this is along the track is 56 meter and across the track it is 79 meter. So this is 79 meter. Now we have to say which of the following option is true.
Your internet was gone for a while now.
Okay, so I will repeat one more time. So we have been given with the image in which the along track and across track dimension of the pixels is given. So along track it is 56 meter. This is the along track, and
Got
this
it, got it.
across the track it is 79 meter. So we have to say which of the following option is true. So do you know anything about aspect ratio? What will be the formula, or what do you mean by aspect ratio?
It's the height into width, height
Not
upon
into, not into. So
upon.
if we have a square, aspect ratio will be 1. If we will convert into rectangle, it will be greater than 1 or less than 1. So if we consider the formula, then aspect ratio will be like width divided by height. It's not, so here like across the track divided by the along the track. So 79 by 56. So if we do that, which is like aspect ratio is the ratio between across the track pixel and along the, basically this one divided by this one, 79 by 56. So aspect ratio you will get 1.41, which is like greater than 1. So correct option is option A. So I think like how we can analyze this question is like we know that from this only anyone will be correct, anyone will be wrong, and these two are definitely wrong because there is no geometric distortion in the image. Like anyway, if we take any image, it will have some geometric distortions, and then aspect ratio distortion is a type of radiometric. So it is not a type of radiometric; it's type of geometric distortion because it is changing the like features which is on ground. So it's kind of geometric distortion, not the radiometric one. So that's why the C and D are incorrect, and from A and B, the option E is correct. Now, the- you might be knowing about the color theory from your schools. So the next question is based on that subtractive and additive color theory. So which of the following is right in case of the color theory?
Subtractive is used for color printing, so I think A is correct.
So it is a multiple choice. So subtractive is where this additive might be used.
Additive is used for color television, so B is also
Exactly.
correct. And white light projected on translucent filter made of yellow dye subtract
So I will
light over
give you a bit hint for this.
uh-huh.
So
Correct.
now you have additive and subtractive colors theory. So as you told, like additive is used for the digital images and subtractive is used for color printer like CMYK. Now these two are correct. Now we have to check whether C and D is correct or incorrect.
Subtract, but which color theory are they talking about in C and D?
So that you have to identify.
So that is light, so the light it might be additive. So
Yes.
then
So
C is
yeah,
correct.
which one is correct?
C.
C is correct.
A and B are correct,
C is
and
also correct as you saw.
C is also correct. Yeah, white light projected on
Hmm.
translucent filter made of cyan color would subtract green light is wrong. D is wrong.
Uh, because it will subtract the which light?
Red color.
Red color. So this is the cyan color. So if we know here this particular, so it will like have a addition of blue and green color, and it will subtract the red color. So that's why that option D is incorrect. If we see the option C, then it's a yellow color. So it is a combination of blue and green color, and it will subtract the blue color. So yeah, that's it. So after this, the next question is that if we have, let's say, a sensor which converts the lights into different voltage change, like are based on the intensity in general if you think. Then a sensor has a voltage range from 0 to 5 volt, and the maximum number of codes that it can quantize, or the voltage change, or basically the intensity which we can have, like it is up to 2048. So the bit size of the quantizer is, so here they have used some difficult word, but what you have to focus over here is, like we have to show the intensity change up to 2048. So, like, what will be the quantizers?
10,
Yes.
10. 10 is the answer. No.
Yeah. So, what we have to do is we have to just do the 2 to the power n should be equal to
So
204.
11.
Yeah. So, based on that, you have to find out the value of n. So, it will become 11. 2 raised to 11 is equal to
11.
4.
11. 11.
So, yeah, our answer will be 11. So, the next one is like 4-band multispectral image is there with the size of 64 by 64 pixels, and it also has a header file of 560 bytes. So here what we have to do is the, like, as the similar question, how much storage we need to store this image in terms of bytes. So first of all, like we will proceed in the same fashion that we have the number of pixels. First of all, you can count the how many number of pixels will be there. So we multiply 64 by 64, and it is for 4 different bytes, and each pixel has 2 bytes. So we'll do that. So we have image of 64 by 64. Then each pixel will require 2 byte of data, which is equivalent to 60 bit. And then we have 4 bands. So we'll multiply it with the 4 bands. So you got around 32,768. Is it clear till this point?
Yeah.
Now what it is given is, like, we also need to store header file, which is around 560 byte. So header will be like included as a addition into given data, like to store, like in Excel, like we store the data and on top of that we put the column name. It is similar to that. So what the really header to store the header. So which is equivalent to 560 byte. So the answer will become 33,328. So like that, we have to proceed. First, find out the total number of pixels, then multiply with the pixel depth and the number of bands, and then you will get the total storage required for that purpose.
Okay.
So the next one is a 4-band multispectral image with the pixel size of 50 by 50 meter, covers a ground area which is given like 20 by 20 kilometer. So what we have to do is, like, if the radiometric resolution of the satellite data is 8 bit, then the uncompressed satellite image contains how many kilobyte? So here, I mean, what we have to do is, here it's given a 4-bit multispectral image, which is covering the 50 meter by 50 meter. So size of one pixel is 50 by 50 meter. And that image is covering the area of 20 by 20 kilometer. So let's say if we take the image, then the area of this image will be like 20 kilometer by 20 kilometer. So first of all, we will find the area of image, which will become 20 into 20. So it will become 400 kilometer square. Now we know the pixel size. So what we will do, so like pixels will be like this. So we will divide it by the area of one pixel. So we will get how many number of pixel is required in the image. So we will do like 20 by 20 divided by 50 by 50, and we converts the units into proper units, like either meter into kilometer or kilometer into meter. So that will be like our first step, because here also we have to find out the how much like storage it will take. So the best idea to do is to find out the number of pixels, and here the number of pixels are not given directly. So what we will do, first of all, we will divide the entire image area with the area of 1 pixel. So it will give us the total number of pixel, and then we will divide like multiply it with the corresponding bits. So is this question clear?
Yeah, yeah.
Okay, so just do it and let me know what might be the answer.
So first we multiply 20,000 meters into 20,000 meters divided by 50 meters into 50 meters, which gives us the answer 1 lakh 60,000.
Okay,
And then
yes, one lakh
yeah,
sixty thousand.
pixels. Then divided by um, no, multiplied by 4. But
Multiply
because
by 8 you will do, so you will get total number of bits. And to convert
hmm,
that into kilobyte, you can take. So
hmm,
first of all, like they asked us in the kilobytes only. So we will convert into
hmm,
byte on for like as a byte. So 8-bit means 1 byte. So we know that it is 1 lakh 60,000 bytes only. Okay. Like in
yeah,
first
yeah.
question we did. And it is for 4
Hmm,
band, so we will multiply it with the 4.
hmm, hmm,
Okay, so this 1 is corresponds to 8-bit is equivalent to 1 byte, and this 4 is because of 4 bands. So we will get the total number of bytes. Now, in
hmm.
this case, like you can directly go by two different ways. So either you can just divide it by 1000, as like generally people will solve as a byte and kilobyte as a just like if we consider the words byte and kilobyte, generally we divided by 1000, but in general we know that we have to divide it by 1024. So if it is like subjective type of answers, the both answer will be correct. So either you divide it by 1024 to convert into kilobyte, or you divide it by 1000. So if you divide it by 1000, you will directly get 640 kilobyte. So both our options are right here in this case.
Okay,
Okay.
okay, yes.
Okay. So now we will shift towards the second part of our today's lecture. I just want to ask, is this clear till this point?
Yeah, yeah, it is clear. Yes.
So now we will move to the next one. So where like it is based on the filters. Uh, so first of all, we'll discuss some theory on that, so that it will be helpful for us to solve the questions. So I highly recommended you to go through a book named as a Digital Image Processing by Jenser, Introduction to Digital Image Processing. So in that book, the chapter number 8, which is on image enhancement, which is like a very useful chapter for this NPTEL course as well as for gate examination point of view. So you can go through this chapter where the topics like image magnification, then further topic like what we discussed, right? Histogram stretching is there. Then what we discussed like right now, how much sizes pixels is required, spectral profiles is there. Then the based on spectral profile, like what kind of transformation, ndvi or mndwi or wi, whatever like we can do. And then how to like enhance the image quality, so that like contrast enhancement. So whatever the methods we learned in the previous class, all of it is given here. And then further if you go down, we will be having the some techniques on bend ratio also, so which also we discussed last time, and this I will show the representation of it. So band ratio is like if you have one image which has multiple bands. So here like you have 4, 3, 2, 5, 6, like how n number of bands are there. Let's say if we take Landsat imagery, we have 8 to 10 bands into it. So what if we will take the band ratio of band 1 by band 2, band 1 by band 3, band 1 by band 4, 2 by 3, 4 by 2. So this is like different ratios, and you can see like how we can identify the different features using this band ratio. That like here in this image, the if you see, if we take the band ratio 1 by 2, we will not able to classify the water properly. But here in case of this image where water is clearly visible by black, and similarly if you take this bend ratio of this H tile, which is 4 by 3, it's like very water is very clearly visible. Apart from that, the features which is there on land, it is also like clear distinguishable, uh, which is not like there in the other figures. Here also, like in this figure, you can see the water is represented by white color, and you can see, but the problem with this bend ratio 1 by 4 is that the pixel which you see here, which represents the urban pixels, are like kind of similar. All of them are like looking like black. But if you see this band combination, like band ratio, which is 4 by 3, then you can see here that it has like you can distinguish between the there also, which represents the density of the buildings or urban area which is there. So like this you can use different ratios to discriminate between different features. And then when we talk about this filters, convolutions and all, so we have to like we have one filter which will look like this. So it will be like a rectangular cell, or the focal cell also not, it might be either 3 by 3 or 5 by 5, or it might be in terms of circle, and then this kind of ring. And wedge type also we have different kind of mask. So what we do when we do convolution or filtering, we will like move this mask over the entire image, and we will do the like whatever the filtering methods is there. So basically how will it work, like this is, let's say, our pixel like yellow color, this is the part of the image, and then you are like like moving this 3 by 3 filter over the image. So this value is like 0, 1, 3, 2, 5, 4, 8, 3, 1. So if we apply a filter which is having a let's say low frequency filter which is having the value of 111 111 111 everywhere. So how this filter will work is like 0 cross 1 plus 1 cross 1 plus 3 cross 1 plus 2 cross 1. Like you will multiply all the filter elements with the given element, and you will get the value at the center. So you will get, after doing the operation, wherever this focal pixel is there at the center, you will get the value. So we will left with the uh, edge row which is there, and the top like all the edges. So we will give this kind of image in the filter, and we will get something like this. So now when we talk about the filter, so like what kind of values will be there. So basically if we consider this kind of rectangular mask or square mask, so what will be the coefficient over here which will classify the filter as a low frequency filter, high frequency filter, or some other filters, Laplacians and so on and so forth. So for that, like a theory is there, you can go through it, but we'll not go into that. We'll just see the examples here. So here the different filters are given, and their corresponding coefficients are given in these books. So you can see the low frequency filter has a value of 111 everywhere. So how will it work is like, if you have this kind of image which is representing house, lawn and roads, and the farm is there nearby. So if you apply the low frequency filter over it, what it will do is it will just make the image blur, and all the features which are changing rapidly, like such as edges, and so some like this car is there, or some edges is there between this road and this footpath, or this between these two boundary, so that are not clearly visible to us. Whereas if you pass the high frequency filter, so it will pass on the frequency data which is like sharp edges and the other details into the image, and then it will remove the low frequency feature which is the general feature. So like that, this is the use of low frequency and high frequency. So you apply, if you apply that 111 111 111 filter over your image, it will make it blur, and it will conserve the overall features which your image has. And if you apply the high frequency filter over your image, it will like give you the edges, sharp edges, and the boundaries of the from the given image. So like how your high frequency filter will look like. So basically it has the values like this coefficient which you see here. So 1 minus 2 1 minus 2 5. So all the C2 C4 C8 and C6 will be around minus 2 or very less number, and then at the center you have very big number, as we are focusing on edges. So now these are the other features, like other uh, values of this coefficient for different filters, like which is useful for the different directions to increase the specifically edges in different directions. And then we have some non-linear edge enhancement feature also, which are also known as Laplacian filters. So you can also see the coefficient are like 0, -1, 0, -1, 4. So all the elements which you see here, so it's a 0, 0, 0, 0, and here in the cross you have values. Then it's also like the middle pixel. If you see the central pixel, it has the higher value compared to the other field features, other coefficients. So like different things, if you want to read, you can just go through this book. So here you can see how the Laplacian filter will look like. It will also preserve the edges, but not that as like high frequency filters. So these are the two different Laplacian filters. Further, if we go in detail, there are like you can see the examples of Laplacian filters over here as well. And then you can see this kind of edge detection filter, which are the Sobel edge detection filter and the Roberts edge detection filter and edge enhancement filters. So those Sobel says like filters are like if you have either one row which is central row or central column 000 or 000, that is specified by Sobel filter. So like you have to use this filter and apply it on the given image, and it will give you the different boundaries, or like whatever the kind of high or low frequency it will pass. Or you might have different filters also, such as band pass filter or band stop filters. So these are the some of the example like how this filtering will look like, and how your image will look like in this different domains like you pass the filter. So this is like original image, and then low frequency it will become very blur, in median also minimum, then it is a maximum filter, then is a high frequency filter which is like useful for edges. So you can see now how the edges are being clearly defined in like so basically this is the path of effluent which is mixing with the river water. And then this embossed northwest and northeast feature, like it will preserve the data in those directions. So here you can see the like like this is the like whatever the object is there in between, whereas the high maximum amount of flume is there at the center, that you can identify using this compass northeast filter. Whereas this northwest you, so it depends, not only depends on like direction, it depends on the all the elements which you have in your image. And then these are the other Sobel edge enhancement and Sobel edge enhancement, and this is the Laplacian filter. So I mean, you can learn more about those things from these books. And this thing, I think it's important. Some other topics we'll discuss during the PPT only. So now, what is given to us is they have given us one image which is having the pixel 67, 67, 72, 70, 68, 71, 72, 71, 72. And we have given a filter which is 1 by 9th, having the value of 1 by 9th. So first of all, like this is which kind of filter?
It's a low pass filter.
Low pass filter, exactly.
Filter.
And how do we find out the central pixel value? So
we'll have to just add all the pixels and divide by 9.
Yes. So just do that, and this question being asked 2 times in a GATE in the last 3 years. So I will do also along with you. So we have 67 plus 67 plus 72 plus 70 .
Yeah, 70, correct.
Yeah. So the of you will get the first option. So after that, like we'll get 68, 71, 72. So you will get the option A, 70. So 67 plus 67 plus 72 plus 70 plus 68 plus 71 plus 72, 71 plus 72 divided by 9. So the next thing questions are based on Fourier transformation. So this topic is not covered in the lectures, I think. So we'll cover this a bit in just not depth, but it's just from overview part. So this is the image given to us from the Colorado River Basin, which shows the meanders of river. And here you see we have selected 3 different images. from three different parts of the figure. So the first one is represents just calm water. The second one is represents the just where this kind of little bit terrain is there, uh, and then on the B, like B, where you have C, where is like which is the area near to the river and the like top terrain, and the B is like where top terrain and hills are there. So now you can see, like if you consider all the three images, this image is very calm and there is no changes happening in this image as particularly. Here, if you see the second image, it has some horizontal features, vertical features, and some features are changing randomly also. Some features are changing smoothly. Here, if we see the third image, you can see like it is just having sharp edges, which is going in the northwest and southeast direction, which is the linear feature, which is you can see that this is the terrace boundaries. So here now, what we are doing in this particular transformation is that we are converting our image, which is in spatial domain, to the frequency domain. And why we are doing it is because like frequency domain is basically it will give us the overall features which are there in the image. Basically, the low frequency feature will represent the overall terrain or overall image, and then we have the high frequency nodes which will represent the different edges and different features which are varying sharply in the image. So why this thing is necessary if you have multiple data sets to reduce the uh, tendency of the data, like if we have in the hyperspectral image, and then some case if we need to use this particularly transformation to convert the like do the atmospheric corrections as well. So in the earlier classes we learned about the de-stripping. So the sensor error in which you will see these stripes. So what we will do, we will plot the Fourier transformation of it. So when we plot the Fourier transformation, it will show us the first of all whatever the image is there, it will show the low frequency feature which is on the center part. So whatever this white color you see in each and every image, that is the low frequency part. As you will go towards the edges, it will show us the high frequency part. So here in the center, you will be having the low frequency part, and if you will move towards the edges, it will like increase the frequency. So if you go from center to edges, it will go from low frequency part to high frequency part, and then low or medium moderate frequency part. And then if some image has some particular feature which is changing very sharp, then you will see these lines. So this line represents the different sharp feature in horizontal and vertical directions. So basically, this line will represents the high frequency, and here you can see this. You can see this strips, which is like in this direction, which is going from like you can see it's like from north west to it is going the southeast. So it's going like this, but here it got converted like this. So it got image axis got flipped basically. It's earlier it was like this, and then if you plot the Fourier transformation of that image, it got flipped in the other direction. So this is the like low frequency part, and then these are the very high frequency nodes, and then this is the these strips which you are seeing here. So it will convert your image like this, and then you will remove from your Fourier transformations, you will remove those things using any filters, and then after you will convert it back to the original image using the reverse Fourier transformation, and you can remove the atmospheric noise or some kind of sensor error which you have in your image. So this is like have very different applications, but we will not go into that right now. Based on that, we will solve some questions. So if you have an image like this, okay, for Fourier transformation, so here they have highlighted the zone A. So which kind of frequency will the zone A will represent?
Low frequency.
Exactly. So we'll see that here it's like black color was there, so low frequencies were very high. And like you see here, most of the image is gray image rather than it's going black in the corner. Whereas here in this, you have sharp edges and high to moderate frequency features also there. So if you go to this towards this like edges and corners, you have very dark color as well. So then you have mild frequency, low frequency, mild, and then moderate frequency, and high frequency will be like at the spikes at this like these lines, if it is has. Then the next question is you have to find out the correct statement from the given four option, which is on
Okay.
Fourier transform.
Okay. Higher frequency original image predominantly appear around the center of the Fourier is false. Higher frequencies in an original image progressively along the outer edge is true. Um, A is false, B is true, so B is correct. C, horizontal features in an original image appear as vertical components. That is also true. So B and C are true. Sorry,
And
what did I say? Yeah, correct.
the B
Then
and C
D,
are true.
yeah, vertical features in an original image appear as vertical components. No, false.
So
So only B
because
and
it
C.
swaps the axis, so vertical part will become horizontal, horizontal will become vertical. So option D is wrong. So option only B and C is correct. So now we have given, so like if you will go through the book, you will like able to solve this question very well. So what it is given us, like different four filter is there, and for we just have to match the following. So first of all, can anyone tell me like which one of the following is a low frequency filter, which is like very simple to tell.
So P is low frequency,
So
belongs to P.
I relates to P. So option A and C might be correct. Then we will see the high frequency filter. So any idea about
Four
that?
is Sobel is Q.
Sobel is Q1. So I4 is like fourth one is Q. So option C is correct
C.
in that case. Okay. And now if we just see like we'll just check it out the other options are right or wrong. So first of all, high frequency filter. So at the
I
center you will, yeah,
I think Laplacian is S and high frequency is R.
R,
I'm not
yes,
sure.
exactly. So high frequency is the R1, which all you also had in lectures as well. And this one is a Laplacian filter, which is like all the corners are zero. So this is Laplacian filters. So here you can also see this second, which is R. This high frequency is R, and this 3 1 is S. So Laplacian is S. So option C and option D both are correct here. Okay. Any doubt in this question?
No.
So now it is given that which of the following filters can be used to suppress the low frequency component of a raster image.
Are there multiple answers to this or
No,
single answer?
just multiple answer. It's a multiple choice answer.
Then 4. 2 and 4.
2 and 4. So why do you say 2 and 4? Any logic behind that?
Because the sum of coefficients is almost equal to 0, which is a sign of high pass filters.
So what here we have to do is we have to like suppress the low frequency. So we have to select the high pass filter. And in high pass filter, if you know that the central pixel value will be very high, that's why it will give us the sharp edges and the changes which is happening very sharp. So all the other values will become around zero. So that's why option like 2 and 4, which represents the B and D, are correct. So that's it. So those are the questions related to the image processing which we covered. So any doubt till now? So
No doubt till now.
so I think we have covered like most of the questions from the second part of uh, GATE examination paper and the last 3 weeks of our NPTEL class. So I think there are few questions which is based on Fourier transformation or few one which is out of the context of this syllabus, which is not that much. 2 or 3 questions are there in the last 3 year paper. So you can go through those papers. If you have any problem in that, just let me know. Apart from that, like Any doubt in this section? Last class we did one question wrong, which is related to the NDWI. So we have used, I think, formula here green and blue, but the correct formula is green and near infrared. So just take a mind of it. And the problem with the last class lecture was like I don't know, somehow my audio does not didn't get recorded in the last class. So I might do the recording one more time and will upload that. So it's already there on YouTube, but I don't know, audio is not there. So I will try to like record it, and like I already recorded, I will just re-upload it one more time. So that's it. So now I think in the next two lectures, as I discussed, we will solve something on GIS, and then after some questions based on like one case studies we will do. So in case studies, we will go through the manual which I have given to you. So just let me open it. So one thing I think, so we did not like at the end we discussed about the vector analysis in our QGIS hands-on session. So now what we will do is we will see few examples on interpolation, like how to do interpolation in QGIS, and then how to handle the raster data in QGIS. And these two topics we will cover. And apart from that, there are few case study questions which is given to us, which is related to the finding out the particular site, like given the different criteria, you have to find the site which fulfills the all the criteria. So it's a different, it's kind of analysis. So we will do this particular question where you have to find out the particular area in the hilly mountains for the campsites. So that we will do. And I think what we can do is right now we have few time, like some time is there. So we will see in QGIS like one topic which is on interpolation, which will not take much time. So we'll cover the one method of interpolation, which is like IDW method, so inverse distance weighted method. So in that, what we do is we take the like as we did in the classification, minimum distance classification, we'll find the difference, like distance between the nearby point, and give the weightage to the data and find out the interpolation. So basically, if your data has something like this, so let's say if data at this red point is given to you, which is the data related to the temperature, and you have to predict the temperature at this purple point. So what we will do, we will first of all find out the distance between all the point, and then we will, based on that, we will give the weight. So this point is very near to this point, which we have to find out
Hiren,
the.
you can't be heard. Your internet is gone.
Okay, so just a minute.
Hiren, I
Yeah,
can't hear you.
yeah, since like when you were not able to follow me, from which part?
You had opened the image that you had googled to show the meaning of
Oh,
inverse distance.
okay, okay. So here, see, here I have the 4 pixels at which I know the actual temperature, which is 12,
परत
10.
गेलं.
Again, it's not, there's still issue with my voice.
I understood. Okay. Estimates unknown values from with specifying search distance. Closest point power setting barriers.
So I
Are you there?
Yeah, I'm there. Just let me check my connection, why it is happening.
Inverse distance weighing interpolation. Weighting
So
interpolation.
I think,
Estimates the unknown values with specifying
hello.
search distance.
So are you able to hear me? Yeah. So hello, are you able to hear me now?
Yes, I am able to
Yeah.
hear you now.
So what I will do is I will just go through that topic, and then like we will also discuss from the same topic from the next class as well. So if in between I get disconnected or my voice is not audible, so it will be there in the recorded video, and we will just discuss go through that one more time.
Okay, okay.
So we'll cover that in Monday part if it is not then being done. So first of all, here at 4 points, we know the temperature, which is 12, 10, 10, and 9, and we have to find out the temperature at this location at purple. So first of all, we will find the distance from this point at every other locations. So like this Euclidean distance we will find, and so from this it is 350 meter, from here it's 850 and 750. So like that we will give the weightage. So if the site is near to the if the location is near to the point where we want to find the temperature, we will give more weight to that particular site. So here like the value 12 is having the 350 distance, value 10 is having 750, and 10 other 10 is having the 850 meter. So what we will do, 12 divided by 350, this distance, then 10 divided by 750, and 10 divided by 850. So this is the weight, and divided by 1 divided by total distance. So it will like inverse distance, because we are giving 1 divided by distance. So that's why it's the inverse distance, is known as the inverse distance. And we will get the value as 11.1. And this is the power 1 or degree 1 inverse distance. If we want to consider the degree 2 inverse distance weight, then we will divide it by d square instead of d. So this will be like generalized formula for the inverse distance for the p polynomial, power p, which is the power of the polynomial. So you can see it's z is the value, which is might be a 12, 10, or 10, and d will be the distance, and p will be the what order of IDW method we want to use. It's a first order, second order, or third order. So based on that, we will give weight to the points. So is this method clear? I mean, like
Yes,
how
it is
we will
clear.
provide. So first of all, I will go to
Yeah,
this QGIS, and I will open any few datasets where I have some points of. So I will go to my
can't hear.
folders. So I will go to my folders, uh, and open the folder which is like, so this is the data which I given to you. In that, day 12 interpolation folder is there, and then Gujarat well level data is there. So this is a CSV file. So we will open that CSV file using the delimited text datasets.
Yes. Back.
So we will open the CSV file like this, and it has latitude and longitude, and we will add this CSV file, and it will show us the data like this. Now let's say we want to do the interpolation here. So what we will do is like we will go to this. So first of all, we'll see which part of the this data is from. So we'll put the OpenStreetMap or any other base map. So this data is from Gujarat region, and then now we will do the IDW interpolation. So I will write IDW, which is the tool in QGIS. I will select IDW interpolation. Now here, first of all, it will ask me the data file and then parameter which you want to interpolate. So let's say we want to, so basically we'll see the attribute table first of all, like what kind of data it has. So it is having the well location, well name, what is a village, site name, type, and then you have the depth of well, then the what is the water level before monsoon and after monsoon in 2021, and type of aquifer it has. So what we will do, we will just try to see what is the average well depth in the area, or we will find out the like raster image of the well depth. So we will select the well depth attribute, and then we will click on this plus sign, and then here the distance coefficient. So this p value, which is like second order, first order, or what kind of order distance coefficient you want to use, that you have to give here, and then extend. So for how much area you want to do the interpolation. So let's say I want to do interpolation in the this much area only. Let's say, so I will click on draw on canvas, and let's say I want to do interpolation in this area only. I don't want to do it for entire image or entire data where I have data. And then here you have to specify the output raster size. So whatever the output you will get as a raster image, what will be the size of that particular image. So I will keep it as 0.001 degree, and then save your file and run it. So it will generate a raster image which will give you the depth of the groundwater. And now you can see the histogram, like it which depth it has more number of like what is the overall depth of the water level. Then you,
He,
yeah,
Hiren, your internet was very shaky last 5 minutes. I have
okay.
not seen the part of QGIS that you did. I
Okay,
couldn't
so
see. I
you
only
can
saw.
go through the video, okay,
Acha.
because like I recording is happening, which is not like internet based, so it will be
Acha.
there in
Okay.
the video. And what I will do is like I will cover the same part in the next class also, the interpolation part. So you, if you have any questions, so it will be get like covered there as well.
Is your QGIS by chance open or did you close it already?
Yes, it's open.
Open. Can you show me the last output only?
Yeah, it will be like this. Is it visible or not?
No, no, you've not shared your screen.
Okay. So it looks like this.
Okay, got it, got it. Understood, understood. Fine, fine. Got it. Yeah.
So we just don't have to do anything. We just do have to click on IDW. We have to select the attribute which we want to interpolate, where whatever like well depth or the well level or water level before monsoon, after monsoon. So whatever the field we want to take it, click on this plus sign, and then here you can put the distance coefficient, which is like we discussed in the
Agree.
image
Mm.
p value, and then here you have to specify the pixel size, what will be the size of the pixels which you raster image which you will get. So I will specifying it as a 0.001 degree, because my original data is in degree only, so that's why it will give me the image in degree as only. If it is in meter, you show like specify 10 or 20, whatever you, and then just click on run. It will give you the image like this. Afterward,
Understood, understood.
afterward, like you can change the symbology and you can make a contour, because generally groundwater data we will represents using the contours. So you can put a contour with the interval of like 10 or 20. So you can put a contour of 10 and it will give you the image like this,
Wow.
and you can
Nice,
add
nice.
the labels and everything afterward. Okay. So that's what like I want to discuss. No worry, I will like my internet connection is, I don't know why it is changing a lot today, but we will cover this thing one more time in the next lecture. So next lecture we will cover this interpolation part, and as well as some questions on the raster analysis, where we will work on DM data sets, and then this how to process different layers in QGIS, whether it's raster or vector layer. And then in the last class, we will see some questions on GIS part, which been asked in the GATE examination as well as an NPTEL exam. So is it fine?
Yes. All good, all good.
Okay, so
Yeah.
we'll proceed in that way. So like just two class I think are remaining. So we will do that and we'll wrap this course. Yeah. So
Okay.
thank you for
Okay.
joining. We'll
Thank you. Thank you.
close
Thank you
this
so
section.
much.
Okay.
Yeah. Bye.
Bye.
Bye. Take care.
And
Bye.
sorry for
Bye.
this internet issue today.
No problem at all. We will continue next time. That's all.
Okay, fine.
Okay.
Bye.
Thank you. Thank you. Thank you so much. Bye. Bye.